Working with trigonometry or Pythagoras' theorem in 3 dimensions requires just a few extra skills. One is it's handy to be able to draw the picture in 3 dimensions, but it's even better to be able to take that drawing and re-visualise each of the triangles in the drawing in 2 dimensions, because this really helps you to keep things simple and find a plan to get to where you need to go. Now, if your drawing doesn't have any labels on it, it can also be really useful just to label the key points. Let's call these A, B, C and D. Let's call the base here, I don't know, M. Let's call this T for top, M for middle. Okay, so now I've got some points here. If I start to draw other triangles, it's really clear where they would fit on my original drawing. Now the point here is that I need to find the height of the square pyramid. It's a square pyramid, so I know that if this is 8 centimetres, the other sides are 8. Now one of the first things you might like to do is a plan view, because it can be really helpful to think of what this thing looks like when you're looking straight down on it, like an architectural drawing. Now it's a square, so if it's 8 centimetres, you can think what that looks like. These lines in blue going to the middle are going to be the diagonals of a square, so they'll meet at right angles. Okay, so it's quite easy to work out what any one of these lines would be. And just by drawing that picture, you can start thinking that through, that if you need to find one of those, you'll be able to. Now the other thing we know about the picture is that this angle is 60 degrees. So if we draw that triangle separately, all right, we've got it going up to T for the top. Now there's 4 of them that are identical, so it doesn't really matter which one we draw. How about we draw the one that's actually at the front here, because it's sort of nice and easy to visualise A, B and T. So A and B. That way we know that AB is 8. All of those base sides are 8. And we know that if this is 60, this angle over here would also be 60. So we can put the 60 degrees in. Okay, now so far you've only done trigonometry with right-angled triangles, and this wasn't a right-angled triangle. What did I just sneakily do there? Well, I just dropped a line straight down from T that would finish in right angles here. And the reason I did that is because now I've got a right-angled triangle, I can use both trigonometry and Pythagoras' theorem much more easily. Now, all 4 of these slanty lines coming down from the top are going to be equal in length, because square-based pyramids have that feature. So I know that these 2 sides are the same. Now, keep in mind where we're going. We're trying to find the height of the square-based pyramid. So we're actually trying to find this height here. Okay, now we can't find that just yet. We certainly can't find it from either of the triangles that we've drawn, and yet these are the only 2 triangles that can give us any information, so we sort of need to start with those. Now, looking at where you're going, it would be handy to sort of think, well, if we knew, say, the length of this slanty side, and we knew this, then we could use that red triangle as our method for finding the height. Okay, now we wouldn't know the angle necessarily, but if we knew both of the lengths, we could use Pythagoras to find the length that we didn't know. So let's have a look at how we do that from these 2 pictures. Finding TB is certainly going to be helpful, so we need to find this. Okay, now if we've got 8 from A to B, how far is it to the midpoint? Each of these would be 4, wouldn't they? Because they're equal in length. So I could basically draw up I only really need half of this triangle. And I'm trying to find this length, which is the hypotenuse, and I have the adjacent side to the angle I know, 60 degrees. So if I have adjacent and hypotenuse, AH, which ratio do I need? Yep, that's right, I need cos. So I can go ahead and write cos of 60 degrees equals 4, the adjacent side, over, let's just call that TB. All right, so how do I find TB? Well, in this situation, I can actually always swap whatever is here and here. Can always be swapped. If you weren't sure about that, think about this for a minute. If I have something I know really well, like 4 3s are 12, if I take 12 and divide it by 3, I get 4. But if I take 12 and I divide it by 4, I get 3, because 3 and 4 are factors of 12. Similar situation here. I'm taking 4 and dividing it by TB to get something else, so if I divide it by the something else, I'll get TB. And that's just a little shortcut that you can use often in maths. Now, if you didn't know that quick shortcut, and I'm going to use the shortcut to say I can swap TB and the cos 60, right? If you didn't know that, you could very easily still get to the same line by just multiplying both sides by TB, which will cancel it out from here and bring it over to here. And then to get TB on its own, divide both sides by cos 60. You'll get to the same place. Okay, now I've got an expression for TB. I could put this in my calculator and figure out what it is. I could also leave it like that to use later. Cos 60, it turns out that I know what that is off the top of my head. Cos 60 is half. It's one of those nice memorable ones. Again, if you didn't know that, you could type this whole thing into your calculator. Just go 4 divided by cos 60, and we're going to get 4 divided by a half, which is 8. So TB equals 8. Okay, so that means all of these slanty lines up here are 8. And importantly, in this triangle that I'm going for, this red one, which I'm now going to draw, which is T, B, and M, I now know that TB is 8. Now, do I know what MB is? Not yet. Okay, so I need to use this picture to figure this one out. Now, the diagonals of a square are equal, so these two lines will be equal. And the diagonals of a square meet at right angles. It's important to know that about your shapes. So what I've got here, if I just called this length x, say, then this other one would also be x. I can write up, let's do our working for this part over here. I can say that x squared plus x squared must be 8 squared. Okay? So x squared plus x squared is 2x squared. 8 squared is 64. Halving both sides, x squared must be 32, and taking the square root of both sides, x must be the square root of 32. Now, if you've already played around with surds quite a bit, then you might be comfortable with converting that to the square root of 16 times the square root of 2. Square root of 16 is 4, so we've got 4 lots of the square root of 2. So root 32 is also called 4 root 2. Now, if you didn't know that, don't worry, you can just stick with this and use this as your measurement. We're going to chuck this into our calculator later anyway. If you did know that, you'd be saying, hey, I already knew that, so that's cool. All right, let's move to a different colour so we're not going to get confused in here. In fact, let's go to red, because the triangle we're wanting to work with here is red. Now, we've figured out that that length is 8. We've just figured out this MB down here. It's the square root of 32, or 4 root 2. Let's just use square root of 32 at this stage, in case you're not so comfortable with surds. So now, can we be sure that this is a right-angled triangle? Well, yes we can, because a square-based pyramid has its top being directly above the centre of the square. So it definitely has a right angle. So at this point we can use Pythagoras again. We've used trig once, Pythag once, we can use Pythag again to say, all right, whatever this is, let's call it h for height. Height squared plus the square root of 32 squared must equal 8 squared. Okay, so height squared plus, now if you have the square root of 32 but then you square it, you just get 32, and that equals 64. So subtracting 32 from each side, h squared must also be 32. So h is also the square root of 32, which is just a coincidence with this particular question. And we could also call that 4 root 2 if you're comfortable saying so. Now, how else could we name it? Well, we could actually put that into our calculator now and say, what is the square root of 32? We know it's going to be 5 in a bit. And we could round it off to a certain number of decimal places if we want and say it's 5.66. This answer is almost nicer though, isn't it? Because it's exact and it's not rounded off and it's complete. The question didn't specify whether we should leave our answer as a surd or whether we should round it to 2 decimal places. So it's kind of up to you, but this answer, I think here, is the most mathematically simple and correct. So the take-home points here to remember: be comfortable using trig and Pythagoras. If you don't have a right angle triangle and you want one, you can make one by dropping a line down that meets at right angles. Drawing a plan view of looking down on the picture from above can be really helpful. And labelling the parts of your picture help you when you then zone in on other parts of the picture. The other thing that you might want to take from this is that there is a certain amount of flexibility in how you solve this. We went for this red triangle here, but plenty of other people might have solved it differently. They could perhaps have gone for let's draw it in blue, a line coming straight across, so on the plan view one coming straight across. Now we could easily find that length, couldn't we? If the square is 8 centimetres wide, then this is going to be 4. That would save us doing all of this work. It would have been much simpler, really. And then they could find this length coming up here and use that to find this one. So there's all sorts of ways you can walk your way around. Once you find one thing, you can find the next and find the next. And lots of different strategies can help you get the answer.